Our project title is electroacoustic type. Electroacoustic system consists of 6 devices, which is microphones, headphones, loudspeaker, recording, sound reproduction, sound system. The figure shows the loudspeaker diagram. Although the most common transducer in that figure is the moving coil permanent magnet transducer, many variations of acoustic transducer is already exist. The moving coil permanent magnet uses ferromagnetic or rare earth permanent magnets with a high resistance to loss of magnetism.
Here you have a basic mid-range speaker. It's composed of a magnet, voice coil, suspension, and diaphragm. Now I will break down the 4 parts and tell you how they work within a speaker. The electromagnet is positioned in a constant magnetic field created by a permanent magnet. These two magnets, the electromagnet and the permanent magnet, interact with each other as any two magnets do. The positive end of the electromagnet is attracted to the negative pole of the permanent magnetic field, and the negative pole of the electromagnet is repelled by the permanent magnet's negative pole. When the electromagnet's polar orientation switches, so does the direction or repulsion and attraction. In this way, the alternating current constantly reverses the magnet forces between the voice coil and the permanent magnet. This pushes the coil back and forth rapidly, like a piston. This constant movement creates pressure known as compression and rarefaction, as seen in the images provided. The suspension uses the elastic cushion of air within a sealed enclosure to provide the restoring force for the woofer diaphragm. Unlike the stiff suspension of conventional speakers, the trapped air inside the sealed loudspeaker enclosure provides a more linear restoring force for the woofer's diaphragm, enabling it to oscillate a greater distance in a linear fashion. A diaphragm is a transducer intended to faithfully interconvert mechanical motion and sound. It is commonly constructed of a thin membrane or sheet of various materials. The varying air pressure of the sound waves imparts vibrations onto the diaphragm, which can then be captured as another form of energy. And there you have it.